Hi everyone, I'm Herman and I'm going to talk about the credit fraud detection with an autoencoder. We'll talk a bit about the global credit card transaction and then project methodology. Then we'll dive into the EDA and then I'll show you the logic regression as the baseline model that we're going to use as comparison for the autoencoders. So that's pretty much about it. So Capital One reported that the total global credit card transaction was 680 billion in 2022, and US total card fraud losses can reach $14 billion by 2024. So in this project, we are going to train an autoencoder on normal no-fraud data set and use it to reconstruct the data points. Basically, if a data point has a very high reconstruction error, that means the data point is a fraud. So this one is the project methodology. So we have one baseline model logistic regression, and then actually I built four different autoencoders. Basically, those encoders have the same structure, 3-layer encoder and 3-layer decoder. The difference is only the number of neurons in each layer. And for the key performance score, we're going to use F1 recall precision AUC for the precision recall curve scores because we're dealing with imbalanced data. So the credit card fraud data that I got from Kaggle has 1 million rows and it has 8 variables, 1 response and 7 predictor variables. And of those 7 predictor variables, 3 are quantitative and 4 are categorical. And it is an imbalanced data set because the frauds only happen 5% of the time. So based on the quantitative predictor variable analysis, ratio to mean purchase price is the best predictor because it has a very high spike in the histogram. And based on the categorical binary predictor variable analysis, credit card fraud happen more with repeat retailer, more on the online transaction, and occur more with credit cards that don't have chip or PIN numbers. And based on the correlation metrics, ratio to median purchase price is the best predictor because it has a very high correlation with fraud. And this is an example of the logistic regression that I mentioned earlier. We are going to focus on the precision recall curve because we are dealing with imbalanced data. And to pre-process the dataset, this is how we do the pre-processing. And this is an example how we build the autoencoder model. It's very simple. And this is the results of the training. This is for the first model. This is for the second model. This is for the third model. And this is for the fourth model. And lastly, this is the result of the model testing. So as you can see, model number 2 has the best F1 recall and precision score. It is much higher than those of the results from the baseline logistic regression. And then based on the precision recall curve, model 2 also has the best AUC score. So that's pretty much about it. And I hope you like it. Thank you.